In this session, we will be discussing about the slab design and analysis principle and the corresponding IS code, how to configure and its approach. So basically, the slabs you can find in case of your staircase, stair, and also in case of ordinary slab which you use in case of your chaza or in case of your balconies or anywhere where you find the slabs. So here also you have the collective slabs. This will be the cantilever, and sometimes you use the both side support and only one side open, and the type of design which you need, that you need to validate. So our objective is very clear. So we'll be approaching for design and analysis collectively. So here we'll see the developed stress, the vermices stress at the top and bottom, and also the inner level design like the node result and element result also we'll look into, and we'll validate the design. So if you go for the slab analysis, you have to define your fixed edge or the free edge scenario very clearly, and based on that you have to discretize this for getting the result. So how to do this and the corresponding approach I will show in a very simple example, then we'll execute through project. So we'll go to the start and we'll understand this scenario. I'll go to the new project and we'll name it as slab analysis and modeling. I'll go to next, finish. I'll align the slab orientation in the XG plane. Then I will create my overall slab structure, maybe 4 by 6, and I will close this. This is just the skeleton, this is not slab. So for creating slab you have to go for 4 noded plates, and at corresponding nodes you have to click and you have to create a slab like this. Then you have to go to right click, select crusher, beam, and all this beam you have to delete, and also nodes, you can see the corresponding nodes where you have created. So those are the foundation for your slab that you have to keep. Right click, select crusher, plate, this is the plate. Now what you have to do is you have to define the corresponding fixed or free supports, and let us say these 3 ends I will be fixing and this I will keep open. So we have to go to general, support, and create the support fixed, and corresponding nodes you have to select, assign. Now you have to discretize this or mesh it for getting the result. So go to the beam, plate or surface, whichever you need. I need to go to plate, select the plate, right click, and you can go to generate plate mesh. So I can go to quadrilateral mesh with a square size, and here you can define the divisions along the required directions. So 6 meter directions will be AB. Here I need to have 25 division, and again here 25 division because this is 6 meter length, and here I will be defining 15 quadrilateral, apply. So this will be divided. Now you have to attach the thickness to this. So go to command, plate thickness, and I am attaching a thickness of 0.175. The material is concrete, and now this property I will be assigning to my view, so that this will be applied to all the element. Right click, go to 3D render, and this will be my plate with the required thickness. Now here we will see this grid structure, or you can say this is the element. This element we have created, and this we have to fundamentally track it. So inside the grid system, when you define the skeleton, you can define your plates, and by control click you can repeat the plate for future definitions, and this is the final output from one plate in this particular direction, and the G directions you can map this, and finally whatever the thickness you have to attach, that you attach to your plate, and then you load it with your support and you apply the load conditions. So dead load is fundamentally the same as before, but the live load will be plate load, which is a specific load along the y directions that I will show you. So here, if you want to copy a particular element in a particular directions, the same scenario you can use. Right click, select crusher, plate, and whatever the dimensions you have given, that you can check. I'll go to this particular dimension and you can display this, or I can go to the display node to node and you can see. So this is 6 meter. So I'll copy another 6 meter, translate, the directions will be x, number of step is 1 and 6 meter. The same definition is copied, and here I don't need any support. So right click, select crusher, node. So this node where I don't need support, so delete this, go to create and define the corresponding nodes. Go to the top view so that clearly you can visualize your points for support. These are my points. Now you can apply the loading which is specific to your plate. You can go for the dead load. Next you can go for the live load. Go to the dead load. As usual, you can go for the self weight. And the live load, once you select here, you can see here plate load, which is distributed across the plate pressure on the full plate, and this will be negative, let us say 0.15 kilonewton in the directions the global y. Now self weight will compute for all the plates, select all, assign to selected beams or plate, and this also assign to selected plates you can assign. So based on this typical requirement you can do the analysis. So everything is done, and just we'll check about the property, the concrete property with the plate also is assigned. Now you can go for the analysis and you can run a pit delta analysis. So before that we'll go for the load cases. So whatever the load cases you have, here we will go for a repeat load case. I'll go for none and I'll go for repeat, and I will define the combinations between dead and live load. Go to the repeat load case, I will add both the case. I will take dead loads, let us say 120%, and live loads, double click this and define 150%. This is my design criteria, let us say. So now I'll go for the analyze, run analysis. Before that I have to go to the command analysis and go for a P delta, and number of iterations, let us say I am defining 25, and I'll go for all print option and go to analyze, run analysis. Now you can execute and see your results. Go to the post processor and you can select all the load case, enable automatic scaling, mode shape, axial, shear, bending, torsion and stress, everything you can calculate. Based on that you can see the deflections, and now you can play the animations to better understand the scenario. So now I will alter the load case to understand the scenario. I'll go to modeling, go to general, load definitions. This is the same, and this kilonewton I'll be going for suppose 015, and the direction is y. So you have made the changes to the structure. The post processing result will no longer be available. Now you have to go for again analyze, because 150% will be your design strength. So based on that, the solver is again solving for getting the result, and I'll go to post processor and go to OK. And let us see the plate stress type. I'll go for vermices stress at the top layer and go to apply. So this is very nominal, so you can check the different coded form. The red will be with the maximum and corresponding other codes will be the minimum. So this is the stress which you see. You can see the corner stress as well, principal stress, the corner stress, all these details you can find. And finally you can go for the results along line, along any particular lines you can define, and you can create the report also. Cut by line you can do. So you can cut and you can see the report along that line, and you can estimate this also. So you can look inside the result for getting it, and nodal report also you can see. So for better understanding, I'll open from our project folder the slab design, and if you go to the slab design, this is with a typical size which you can see. Just I'll go to the dimension here and I will show you. This is with 330 meter, is a very long slab, and here these are supported. So based on this, let us say you have the load conditions. If you see the load conditions, you have the self weight and you have 0.02 kilonewton per meter square load conditions. Based on that, when you go for the analysis, you run this analysis and you go to the post processing against this load. Here you have the deflections, the plate vermices stress maximum. You can find 260 to 4.33. So 260 is the failure condition, it cannot withstand, where you are getting the maximum cases of the stress. You can see this, and also over the nodes what all maximum deflections you are getting, that also seeing the deflections are very high. So 569 it cannot withstand. So based on different nodes you can see these are very high deflections, so this structure is going to fail. So what we will do is we will introduce the design parameter to it. Whatever the loads you apply either in the staircase or the slab, then you apply the load combinations whatever you consider, and also whatever the deflection you see based on your requirement from this range over these different areas, different contours which you have. So what you have to do is you have to add the design parameters for understanding. So I will show you what you have to do it. I will close this. I will open the staircase project to better understand. So different staircases examples you can see. Staircase, open this. So this is also a composite slabs, and here we have tagged as fixed, and you can check the load definitions. The plate thickness you can see 0.1 meter we have given, and if you see the load definitions, here we have added this as the live load minus 8.5 kilonewton per meter square in y direction. Based on that, if you analyze this, go to post processor, and here you find the plate stresses, one misses top. So 14.4. So as per the RCC property, this is having a good factor of safety, so it's not going to fail. So you have to understand the overall critical areas where you are getting this color, where you have this range. So this color you can see with a very low stress range. The blue colors are this little bit higher, and then this color is the mid tones, yellow, and these colors then, these areas. So you will be having the complete animations for this as well, so that you can understand in the load conditions how it looks like. Next we will go for the design scenario for this slab, which you can add. You can go to the design, go to concrete, go to IS 456, go to the command and go to design of slabs. So design individual elements for flexural moment mx and my. This command has no additional parameter, so just you add this, and this design of element you can select and you can assign this, assign to view, and based on this you can execute the solutions once again, and you can evaluate the errors which you are getting, the total applied load, total reactions load, element force list, and concrete design parameter. So the design moment exceeds the limit moment of resistance per element. So this message you are getting element 44. So directly you can go to the post processor and you can find the complete overall result. And now you can go to the independent members, plate numbers you can see, double click and you can find the geometrical details, the center stresses because of this load or this combination load, the one misses stress also you can get over the top and bottom layers of this plate, and also principal stress and displacement because of these load conditions you can find over these corners, and finally your overall geometry shape. Let us look this scenario for a couple of other options like raft foundation. So go to your exercise folder and open raft foundation, open this. Once you open this, have a look from the side views. This is the foundations grounded at bottom. These all are the fixed areas. And if you go to the property, here you can see the plate thickness for all the range has been defined. If you double click this, here you can see. But the load case you have to understand very specifically for your purpose. So go to the load case details. Here you can see the earthquake load we have considered. You go to this definition seismic. The earthquake for the zone is also joint weight we have considered. This is the factor, and also you have taken the earthquake Z load vectors, earthquake G load vectors for X and Z. The dead load we have considered for all this. And here if you see the earth load, that also we have considered, the bearing load. If you double click this, here you can see the trapezoidal load we have given for this side, so that there will be uneven load distribution. So just you can have a look over this. And water load also we have given, this is also in the trapezoidal form over this side. And finally we have evaluated the combinations of load case through the standard load case which I have explained before. And after that, when you execute the analysis, and here you can see we have requested for the concrete design. Here these are the parameters which I have code Indian, the FY main strength of this primary and secondary, and design of beams and design of columns wherever required also have been given. So based on that, when you execute the run analysis, you can find the design for slabs, columns and beams for your structures, and here independently calculate the stress for independent node where the elements are allocated. So elemental stress will be calculated, and nodal deflections and all properties related to the node and plate like stress and strain and stress again of different type, shear stress and the bending and all will be calculated, and based on your requirement and your safety precautions you can check for your design, and then you can validate and you can make it okay. So now we'll see the solutions, and in the post-processing mode we'll evaluate the report. So calculating the section force, concrete design, element stress, the section force, and all will be calculated one by one, and you can see the joint stress file are computed, and that will be applied to your structure. Go to the post processor, and based on all these load cases your design will be computed. If you go to the plate, the plates 1 meter stress top will be computed, and here you can see this is reliable and is having very good response, and which area having which stress distribution. Here you can see you have the maximum stress at this corner, and if you go to the beams, over these beams also you can see the shear force and bending diagrams, as well as here you can go to the graph and independently you can follow and you can see the safety. So this is the Raft foundation where you can apply this advanced concept and understand the safety before validating the design. Thank you.